In this video, we'll talk about the indeterminate forms and LHopitals rule, which is given in 5.6 from the book, section 5.6. Okay, so you remember that how did we find the limit of this function? Okay, to find out the limit of this function, the first thing we do is you plug in the limit directly, right? If you plug in the limit, what do you get? You get 1 square is 1 minus 1 over 1 minus 1. That will be 0 over 0. So if you get the form 0 over 0, we call indeterminate form. We don't know how much is that. Is that a big number or a small number? Is that 1? No, it is not 1. Okay. So we don't know how much that number. So we call that type of form is called indeterminate form. Okay. But how do I find out the limit of this type of function? In case of you get of this form, or infinity over infinity, sometimes you get that too. In that case, you try to simplify the top and bottom and find out the limit, right? So how do we do that? You write limit x tends to 1, and you can write that as x minus 1 times x plus 1, because it is like a squared minus b squared. If you get the factor, you'll get a plus b times a minus b. And what you do next is you cancel out the common factor, you divide, right? So what is left there is x plus 1. You see that? And then finally, when you plug in the limit, now after you get the lowest form, you plug in the limit, and then you get 1 plus 1, that is 2. So the limit is 2, meaning that when x tends to 1, the graph of this function has height almost 2. Okay, so this problem was not very bad because we were able to get the factors on the top, and then bottom was already in the factored form, and then you were able to cancel. But if you get an example like this, e to the x minus 1 over sine x, we cannot factorize like this here, right? And if you plug in the limit right away, you will get e to the 0 minus 1 over sine 0, right? You get 0 over 0. See why? Because e to the 0 is 1 minus 1. So 1 minus 1 is 0, right? Over sine 0 is 0. So you get 0 over 0. But how do I handle this type of problem? Because I cannot get factors here, right? So that is the problem. So to handle this type of problem, there is a rule we call LHopitals rule. Okay, we'll talk about that later. There is a very easy way. I mean, to do this problem too, you don't have to do the factorize. So you don't have to factor. So there is an easier method to do this problem too, to find out the limit. Okay. So let us talk about the indeterminate form. If a function takes a form 0 over 0 or infinity over infinity at a point, the point can be a finite number or at infinity. That can happen, okay? Then it is called indeterminate form. So either 0 over 0 or infinity over infinity. When you plug in the limit right away, if you get one of those form, then we call that as indeterminate form, okay? And then other type of indeterminate forms are infinity minus infinity, 0 times infinity, 1 to the infinity, 0 to the 0, and so on. So why they are the indeterminate form? Because these forms can be reduced to one of these forms. Okay. For example, this can be written as something like, you can think as like 1 over 0 minus 1 over 0, right? That will be basically kind of, you can think of 0 over 0, right? And here, this one can be considered as 0 times 1 over 0, right? So 0 times 1 is 0 over 0. So that gives you 0 over 0. So here, if you take natural log, you will get infinity and then natural log of 1. That will be 0 times infinity, or this is because this is 0, right? And 0 times infinity. Similarly, this one is 0 times infinity too. So since these forms can be reduced to one of these 0 over 0 or infinity over infinity form, these are also the indeterminate form. Let me clearly list the indeterminate form, okay? When you plug in the limit, if you get one of these forms, then we call indeterminate form. There are 7 of them. So one is 0 over 0 is indeterminate form. If you get infinity over infinity, that is also indeterminate form. If you get infinity minus infinity, that is also indeterminate form. Another one is 0 times infinity, that is also indeterminate form. 0 to the 0 is also indeterminate form. 1 to the infinity is also indeterminate form, and infinity to the 0 is also indeterminate form. So the very basic indeterminate form are the number 1 and 2. the all other indeterminate form can be reduced to one of these form. That's why these are also the indeterminate form. Okay, guys? Okay. Now, so when you plug in the limit directly, if you get one of the indeterminate form, how do we handle that type of problem is given by the LHopitals rule. Let's see what it says. If f and g are differentiable in AB containing C, suppose the interval AB contains a point C, and suppose f and g are differentiable everywhere in AB except it may not be differentiable at C. Also assume that the derivative at all the points in that interval is non-zero except possibly at C. So the function f and g must be differentiable everywhere in between A and B except at C, or it may be except at C, but it should be differentiable everywhere between A and B. And then also if the derivative of g is non-zero everywhere except at the point C, and if the limit x tends to C fx gx, if this limit, you see that, if this limit produce an indeterminate form 0 over 0 or infinity over infinity or any of these indeterminate form, then that limit x tends to C fx over gx can be written as limit x tends to C f prime of x over g prime of x. What does it say? It says that if you're trying to find out this limit, you can find out the derivative of the top directly and the derivative of the bottom directly, and then plug in that limit on the derivative. You don't have to do the quotient rule here. Just find out the derivative of the top and find out the derivative of the bottom. Okay? And then find the limit. So that limit is same as that limit. Okay? So provided that the limit on the right exists. If the limit on the right hand side is a finite number, that's the answer. If the limit on the right hand side still gets 0 over 0 or infinity over infinity or any of these indeterminate form, then you'll continue doing that. Okay? So one of the very important thing on the LHopitals rule is you need to have a function on the top and a function on the bottom. Otherwise you cannot use that form. Okay? You need to have a function on the top and then divided by another function on the bottom. And if you plug in the limit directly, if you'll get 0 over 0 or infinity over infinity or one of these form, then what you do is you try to find out the derivative of the top only separately and the derivative of the bottom separately and plug in the limit. If you get a finite number, that is the limit. If you don't get, and then you'll have to if you get 0 over 0 or infinity over infinity like indeterminate form again, then you'll have to continue. Okay, so the things will get clear once we do the example. Let us do the exactly same problem here. Okay, like the example that we discussed. So use the LHopitals rule to find out the limit of these functions. Okay, let's see that. Let us plug in the limit directly. You'll get 1 square is 1 minus 1 over 1 minus 1 is 0 over 0, which is the indeterminate form. The LHopitals rule, let me write down LHopitals rule. LR is the LHopitals rule, implies that in this case when you get 0 over 0 you can find out the, let me write the limit on the top, limit as it is, find out the derivative of the top. What is the derivative of the top? Is it 2x, right? 2x divided by the derivative of the bottom is just 1 because the derivative of 1 is 0, 1 is 0 there, right? Now plug in the limit. If you plug in the limit, do you get 0 over 0? No, you don't get 0 over 0 anymore. Now plug in the limit then. So 2 times 1 is 2, over 1 is just 2. That is the answer. So you don't have to do all these simplification. It is just easy, right? Find the derivative of the top separately, find the derivative of the bottom separately. Never make a mistake by doing the quotient rule here. You don't have to. Just find the derivative of the f, find the derivative of the g separately and plug in the limit. Let us do the second example that we were not able to do it, right? When you plug in the limit here, you get e to the 0 minus 1. E to the 0 is 1 minus 1 is 0 over sine 0 is 0. We got indeterminate form. So we are okay to use the LHopitals rule. Okay, we are okay to use the LHopitals rule. Okay, let's do that. So this function basically, both of the function, the top function is differentiable everywhere, the bottom function is differentiable everywhere. So you don't have to worry about the assumption there. And here also the top function is differentiable everywhere and the bottom function is differentiable everywhere. Okay, so we don't have to worry about that. Okay. So let's use the LHopitals rule equals to, let's use LHopitals rule. What you do is write down the limit. since it takes the form of 0 over 0, you can find the derivative of the top. What is the derivative of e to the x? E to the x itself minus 0, because minus derivative of 1 is 0, over what is the derivative of sine x? Is cosine of x. Now you plug in the limit. What do you get? E to the 0 is 1 over limit x tends 0 is cosine 0 is 1. So it is basically 1 over 1. So the answer is 1. See how easy it is. You don't have to factorize, you don't have to do anything. Just find the derivative of the top, derivative of the bottom. But you need to have one of these indeterminate form to use that L'Hopital's rule. 0 over 0 or infinity over infinity. Okay, that is the main. And other indeterminate form can be changed into one of these. So they are also okay. Let's do this example. So what is the what form does it take if you plug in the limit? Limit x tends to 0. Sine 5 times 0 is sine 0, right? That will be 0 over 9 times 0 is 0. So basically it is taking 0 over 0 form. So we are okay to use L'Hopital's rule. So how do I use the L'Hopital's rule? Equals to, let me write L'Hopital's rule there. Find the derivative of the top. It is like sine u, right? You see that? It is like sine u. What is the derivative of sine u? It is like cosine. Let me erase that. It is like cosine u is 9x, 5x. Cosine u times derivative of u is just 5 over, let's do the derivative of 9x is just 9, right? Because we are finding the derivative of the top separately, derivative of the bottom separately, and then plug in the limit. Let's plug in the limit and see. So, oh, I forgot to write the limit. Limit x tends to 0. If you plug in 0 here, what do you get? Cosine 5 times 0 is cosine 0 is 1, right? So 5 times 1 is 5 over just 9. That is the final answer. So the limit becomes very easy. But you cannot use L'Hopital's rule for all the limits. Only the limit that takes either 0 over 0 or infinity over infinity or one of these forms can be used, can be found by using the L'Hopital's rule. Okay, let's do this one. If you plug in the limit directly, what do you get? You'll get 1 minus 0 square is 1 minus 0 is root 1. That is just 1 minus 1 is 0 over 0. So we can use L'Hopital's rule here too. You see that? So so what do you get then? So we need to find out the derivative of the top, right? So let's use L'Hopital's rule. So equals to limit x tends to 0. What is the derivative of that? You will do, let me do like this, 1 minus x squared to the 1/2. But let me write down the prime for that. You can do minus 1 and then prime, divide by x and then prime, right? What is the derivative of the top? It is like, for the first, this parenthesis, the things inside the parenthesis, you can take that as u. You see that? This you can take that as u. This thing can be considered as u. So u to the 1/2. So what is the derivative of u to the 1/2? So the u to the 1/2 will be 1/2 u to the 1/2 minus 1 times the u prime minus the derivative of 1 is 0. Divide by 1. Okay, let's plug in the value. Limit x tends to 0, 1/2 u is 1 minus x squared to the negative 1/2, because 1/2 minus 1 is negative 1/2 times the derivative of u is how much? The derivative of 1 is 0 and then minus derivative of x squared is 2x. So that is negative 2x over just 1. So you didn't have to write that 1 basically, right? So let us further simplify this, because this has negative 1/2 in the exponent. I want to move that. But before that, I want to cancel that 2 with 2, because they are the same number in the product form, right? So 2 and divide by 2 is basically 1. You can think that way. You see that? Okay. Let us talk about how it will look like. It will look like this. Negative x, because there is 1, and then times negative x, because 2 gone already. Over this goes to the bottom with positive 1/2 exponent, but I want to write that as 1 minus x squared. Let me plug in the limit there. What do you get? If you plug in the limit, you will get negative 0 over root under 1 minus 0, right? So negative 0 over root under 1, that is basically 0. You see that? So the answer is 0, the limit is 0. So without the L'Hopital's rule, it was almost impossible to, you can do the conjugate, but that takes long time, right? So some of the problems you need to use L'Hopital's rule to find out the limit, otherwise it will be very complicated. Okay, let us do this example. Find limit x tends to 1, x to the 10 minus 1 over x squared minus 1. Let's plug in 1. 1 to the 10 is 1 minus 1 is 0 over 0 again. So it takes the, we can use the L'Hopital's form, right? I mean, it takes the indeterminate form, so we need to use the L'Hopital's rule or L'Hopital's formula there. You understand? Okay, so let us find out the derivative. Let us use the L'Hopital's rule here. So what I want to do here is write down L'Hopital's rule. Let's use that, equals to limit x tends to 1. Okay, what is the derivative of the top? It is 10x to the 9 minus 0, because the derivative of 1 is 0. This will be 2x to the 2 minus 1 is 1, 1 and then minus 0. So that is basically 10x to the 9 over 2x. So can you simplify this? I mean, you can plug in limit x tends to 1, that's not a problem, because you don't get 0 over 0 anymore. Okay, so what do you get? You get 10 times 1 over 2 times 1, right? This is basically 5, because 10 times 1 is 2, 10 over 2 is 5. So that is the final answer. Okay guys, so we will see more examples on how to use L'Hopital's rule. Let us see another example. On this example, you see that you want to find out the limit x tends to infinity. This is the difference you see, right? So far you were seeing limit x tends to 0 or 1 or a number there, but now it is infinity. If you plug in the limit right away, what do you get? E to the infinity square is e to the infinity is infinity, big number, divided by 7 minus infinity cube is negative infinity, right? So it will be infinity over infinity, but it is negative, that's fine. This is still indeterminate form. So what you do next is you want to find out the derivative. You want to use the L'Hopital's rule, find the derivative of the top and find the derivative of the bottom separately. Okay, so let's do that. Let me write L'Hopital's rule. Okay, so that is the derivative. It is like e to the u. You see that? It is like u. This is like u. So it is e to the limit. Let me write down the limit as well. X tends to infinity. E to the u times u prime over the derivative of that thing is 0 minus 3x squared, right? So let me plug the value of u, e to the this is x squared times u prime is 2x, right? Divide by, what do you get? 3x square. You see that? So can you cancel something? Yeah, of course. So that x will cancel with that one of the x there, right? So what is left actually is basically, this is what it looks like, 2 e to the x square divided by 3x. Now if you plug in the limit again, what do you get? Limit x tends to infinity will give you in e to the infinity over infinity. So it is still infinity over infinity. You see that? That is still infinity over infinity form. So we need to use the L'Hopital's rule again one more time. So this is equals to L'Hopital's rule. Okay, I want to use that L'Hopital's rule. I want to write down limit x tends to infinity. Again, you can take this as e to the u, right? There is 2 on the front, but there is e to the u. So you find out the derivative of the top and the derivative of the bottom. So let me write 2 and then e to the u times the u prime divided by 3 times the derivative of x is 1. Okay, let me plug in the values of u and u prime. So 2 e to the x square times, what is u prime, is 2x again, 2x divided by 3. So what is the simplified form? It is 4x e to the x square divided by 3, right? Now let's plug in the limit. Do you still get the indeterminate form or not? So let's see that. So if you plug in that x is infinity, it is infinity times e to the infinity square, that is infinity. So it's a huge number, divided by 3 is still a big number, right? So basically, so the limit x tends to infinity, 4x e to the x square over 3 equals to basically infinity. That is the final answer, right? So let us do another example. This has also x tends to infinity. You have e to the 3x minus 5 over 5x. If you plug in the limit, what do you get? You will get 3 times infinity is infinity minus 5 is infinity. E to the infinity is infinity over 5 times infinity is infinity, right? You are just plugging in x tends to infinity there. So you can use the LHopitals rule. So how do I use the LHopitals rule? So let's write down LHopitals rule equals to find the derivative of that. So you can think this is like a u, right? So what is the derivative of the top? LHopitals rule says that you can find the derivative of the top separately, derivative of the bottom separately, right? So it is e to the u times the u prime over 5 times 1, right? So e to the 3x minus 5 times 3, because the derivative of u prime is 3 times 1 minus 0, right? Just 3 divided by 5. What do you get? Now take the limit. Oh, I forgot to write the limit here. Limit x tends to infinity. So what do you get? If you plug in the limit there, you will get e to the infinity. 3 to the infinity is infinity minus 5. If you subtract a small number from a huge number, that number will be still huge. So I write still infinity when I plug in x tends to infinity and then multiply by 3 and minus 5. And then times 3 is also infinity over 5 is infinity. So basically the answer is infinity for this problem too. So do you remember that I used that formula when I find out the derivative of e to the x? Limit x tends to 0, e to the x minus 1 over x is how much? So let's plug in the limit directly. You will get e to the 0 is 1 minus 1 is 0 over 0. Okay. So what you do is I want to use the LHopitals rule. LHopitals rule. Now I want to find out the derivative of the top separately and the derivative of the bottom separately. So what is that? E to the x minus 0. Because derivative of e to the x is e to the x minus derivative of 1 is 0 over 1. So when you plug in the limit, you will get e to the 0, which is 1. Yes, we use that formula. Limit x tends to 0, e to the x minus 1 over x is equals to 1. This is what we used. Do you remember we used this formula too? Limit x tends to 0, 1 plus x to the 1 over x, right? So what do you want to write? You can write this as, before I use the LHopitals rule, to use the LHopitals rule, I need 0 over 0 or infinity over infinity or one of those form, right? So let's see. When you plug in x tends to 0, what do you get? Limit 1 plus x is basically 1 plus 0, right? 1 plus 0 is 1. So natural log of 1 and then 1 plus x. So basically let me simplify a little bit and then I will plug in those values, okay? So equals to limit x tends to 0, you can move that to 1 over x, you see that, times natural log of 1 plus x. You can write that way. So if you plug in the limit, you will get, what form do you get here? You will get 1 over 0 is infinity times natural log of 1 plus 0 is natural log of 1 is 0, right? So natural log of 1 will be 0. So it is in the form of 0 times infinity, which is the indeterminate form, right? So I want to write this as limit x tends to 0, natural log of 1 plus x over x, because there is 1 in the denominator, you multiply those two, right? If you plug in the limit, what do you get? You get natural log of 1 plus 0 is natural log of 1 is basically 0, right? This is like 0 over 0 form when you plug in that limit. You see that? Now you can use the LHopitals rule. So equals to, I want to use LHopitals rule, find the derivative of the top. You think this as u, you see that? You can think this as like u. So what is the derivative of natural log of u? Is basically 1 over u times the u prime divided by the derivative of x is 1. So what is that? 1 over 1 plus x times 1. You see that? So what is the limit? Oh, I forgot to write the limit again. X tends to 0. So when you plug in the limit here, you will get 1 over 1 plus 0 is 1 times 1 is just 1. So the final answer is 1. So you remember that I wrote that formula when I was trying to find out the derivative of a natural log. Limit x tends to 0. Natural log of 1 plus x to the 1 over x is basically 1. This is what we used. Next is example, evaluate limit x tends to 0 plus x to the 2 over x. You see that? The base is x. That's okay. But the x is in the numerator, in the exponent too. So in that case, see on this example too, 1 plus x to the 3 over x. So in such cases, what we do is we take y equals to, what you do is let y equals to x to the 2 over x, and then we take natural log on both sides. Okay, then natural log of y is equals to natural log of x to the 2 over x. So this can be written as 2 over x goes to the front of the natural log, and then that x stays like that. So basically you can write 2 natural log of x over x. You see that? So now let's take the limit. Then limit x tends to 0 plus natural log of y is equals to limit x tends to 0 plus 2 natural log of x over x. So if you plug in the limit here, what form do you get? Let's simplify this. Okay, you can write limit x tends to 0 plus, right? You can write 2 over x times natural log of x, because it is not the 0 over 0 form. That's why I just separate that. If you do that, what do you get? Limit x tends to 0 plus 2 over x is infinity, positive infinity, times when x tends to 0, then natural log of x will be negative infinity. Basically, you got negative infinity there. The limit is negative infinity. So you cannot use the LHopitals rule here. You cannot use LHopitals rule here. Okay, because it is not in the form of 0 over 0 or infinity over infinity or anything. You see that from here to, if you plug in here, so what do you get? So basically you get 0 to the infinity. So 0 to the infinity is not indeterminate form. So it is not indeterminate form. Okay, no, not indeterminate form. If it was infinity to the 0, that would be indeterminate form, but this is not. So you can guess from here too, but if there is x in the exponent and then there is just one term and then x to the x something over x or just x in the exponent, we usually take we write y equals to that and then take natural log on both sides. Okay, that's the idea. Okay, so let's do that. So what we got is we got limit x tends to 0 plus natural log of y is equals to negative infinity. So how do I get rid of natural log of y? Therefore y is basically e to the negative infinity, right? Because this natural log of y can be written as log of y with base e equals to negative infinity. That's what it means, right? So if you want to get rid of the log, then what you write is y equals to the base to the other side, right? So that's what you write. So you get limit y tends to 0 plus, sorry, x tends to 0 plus y. What is y? Y is x to the 2 over x, right? Is basically e to the negative infinity. So what is the value of e to the negative infinity? It is 0, right? Because it is basically 1 over e to the infinity, right? So if you divide, e to the infinity is very big number. 1 over a very big number is almost 0. So the answer to this question is basically, so limit x tends to 0 plus x to the 2 over x is basically 0. Okay, so let us look at this example. Find limit x tends to 0 plus 1 plus x to the 3 over x. You can see, you can guess your answer, like plug in 0. So you will get 1 plus 0 to the 3 over 0. It is basically 1 to the infinity. It is indeterminate form. This is indeterminate form. So we try to get that, we try to use the LHopitals rule. But before we do that, you need to think that as y equals, let y equals, because that is x in the exponent. Okay, let's do that. Let y equals to 1 plus x to the 3 over x. Now take the natural log. If you take the natural log, you will get natural log of y equals to natural log of 1 plus x to the 3 over x. Okay, for the natural log, that thing goes to the front. So I write natural log of y equals to 3 over x times 1 plus x. Natural log equals to 3 natural log of 1 plus x over x. You can do that way. Now take the limit. Limit x tends to 0 plus natural log of y equals to limit x tends to 0 plus 3 natural log of 1 plus x over x. If you plug in the limit, what do you get? You will get 3 times natural log of 1 plus 0 is natural log of 1 is 0 times 3 is 0. So it will look like 0 over 0. That's what you get if you plug in the limit there. Okay, so now you can use the L'Hopital's rule. L'Hopital's rule. So this is equals to limit x tends to 0 plus. You can think this as like a natural log of u, right? You can think this as like a natural log of u. So what is the derivative of natural log of u? So let me write down 3 here. Times natural log of u is 1 over u times the u prime over the derivative of x. So the derivative of the top and the derivative of the bottom separately. So L'Hopital's rule says that you can find the derivative of the top separately. Derivative of the bottom is 1 there. Okay, so let me plug in the value. 3 times natural log of limit x tends to 0 plus 1 over 1 plus x times, what is the u prime? This is basically u prime. Okay guys, so this is basically u and then prime. Okay, so the derivative of that is u. 1 over u is 1 over 1 plus x. The derivative of 1 plus x is just 1 divided by 1, right? So now plug in the limit. 1 over 1 plus 0 is just 1. So basically 3. That is the derivative of the limit of natural log of y. But what is y though? You need to get rid of natural log. So let me write down that thing. So limit x tends to 0 plus natural log of y is equals to 3. But what is natural log of y means? That means log of y with base e equals to 3. But how do we get rid of log there? E to the 3, right? So limit, so you can write limit x tends to 0 y is equals to e to the third, that is e cubed. That is the final answer. What is y? Y is that value, right? Therefore its limit is limit of y is e to the third. That is the final answer. Okay guys, let me give you just couple more examples. Let us see 2 of these examples. They are exactly the same function, but the limit are different. Here x tends to infinity, but here x tends to 0 plus. Okay, let us see in which problem I can use the L'Hopital's rule and in which problem I cannot. Okay, let's see the first problem. Find limit x tends to infinity x times natural log of x. The first thing you do is just plug in and then see whether it takes the one of the indeterminate form or not. When I plug in x tends to infinity, what do you get? You get limit x tends to infinity x times natural log of x is basically infinity times infinity. So if you multiply 2 big numbers, then that is infinity. So not indeterminate form, not indeterminate. So you cannot use the L'Hopital's rule to find out the limit. The limit is infinity there. Okay, so what is the final answer? The answer is infinity. You see that? That is the final answer. Now in this problem, if you plug in x tends to 0, what do you get? This is 0, right? This is like, if you plug in the limit directly, you will get 0 times natural log of 0 is infinity. So it is one of the indeterminate form. Yes, it is indeterminate form. Okay, but to use the L'Hopital's rule, you need fx over gx form. Okay, because what does the L'Hopital's rule say? Limit x tends to c f over g is equals to limit x tends to c f prime over g prime. That's what the L'Hopital's rule say. But we don't have f over g here. We just have fx times gx. So how do I handle this problem then? Okay, let us see that. So solution is limit x tends to 0 plus x times natural log of x. This can be written this way, right? Do you agree with that? Limit x tends to 0 plus, can you write like this, natural log of x, right, divide by 1 over x. You can write that way, right? Because when you multiply this, if you write in the product form, you can write natural log of x times x over 1, right? So this is basically 1 over x. Now if you plug in the limit, what form do you get? It is infinity over infinity form. You see that? Because 1 over 0 is infinity, there is natural log of 0 is infinity. So this is also, you can use the L'Hopital's rule. Let me write down that. So that can be written as L'Hopital's rule. I'm using that. Find the derivative of the top is 1 over x. Divide by, find the derivative of the bottom. So what is the derivative of 1 over x? Do you know that? That will be x to the negative 1 prime, right? So it will be power rule, negative 1 times x to the negative 1 minus 1. That will be negative 1 to the times x to the negative 2. So basically it is negative 1 over x square. I'm moving that. So the derivative of the bottom will be negative 1 over x square. So I don't forget the limit. Limit x tends to 0 plus. Okay. Now, how do I simplify this? It is basically limit x tends to 0 plus, and if you write that 1 over x times negative x square over 1, there is the fraction of fractions, correct? So I want to write in terms of the product of two fractions, 1 over x, the top fraction times the reciprocal of the bottom fraction. Now if you simplify this, you get there is x divided by x square will be, this is basically x times x, right? You cancel one of that x there. So basically you get basically you get equals to limit x tends to 0 plus negative x. When you plug in that, you will get 0, right? So basically the limit of this is 0. That's what you get. Okay, so that's the difference. See that they are the same function, but the limit are different there, right? And then with this limit it is 0, with this limit it is infinity. Let us look at the last example of this section. So you have find the limit x tends to plus 8 over x squared minus 4 minus x over x minus 2. Again, the first thing we do is we plug in the limit directly and then see what types of indeterminate form does this function take when you plug in the limit. Or is this indeterminate form or not? If it is, then we can use the LHopitals rule. If it is not, then we cannot. Okay, let's plug in the limit directly. You get 8 over, although it is 2 plus, we just plug in 2, right? So you get 8 over 2 square is 4 minus 4, that is infinity, minus, and then 2 over 2 minus 2, that is 2 over 0 again, right? 8 over 0 is infinity, minus 2 over 0 is infinity. So this is that form. So it is indeterminate form. Okay, so how do I do this problem is, so basically what we do is we try to combine these two fractions and then simplify and then take the limit. If you get indeterminate form again, you will just basically you will get 0 over 0 or infinity over infinity, and we use the LHopitals rule. Okay, let's do that. So equals to limit x tends to 2 plus, I want to combine those two fractions, okay, because this is basically x plus 2 times x minus 2, right? Let me write down that 8 over x plus 2 times x minus 2, right? And then minus x over x minus 2. You see that? So how do I simplify this? Is there anything common between these, the first term and the second term? Yes, there is, right? The x minus 2 is common. Let me take 1 over x minus 2 out, and then what is left is 8 over x plus 2 minus just x, because 1 over x minus 2 is pulled out already, right? So limit x tends to 2 plus 1 over x minus 2, right? I want to combine these two. So there is 1 on the bottom. So just multiply x plus 2 times 1 is x plus 2, and then do the cross multiplication, right? You multiply this with that one. So what do you get? You basically get 8 minus x times x is x squared, and then minus, oh, you can write like this, x times x is x squared, and then plus x times 2 is 2x. You can do that way. So basically limit x tends to 2 plus, right, 1 over x minus 2. If you simplify that, what do you get? You get 8 minus x squared minus 2x, right, divided by x plus 2. Now you can combine those two. Okay, let me combine that. I'm not putting the limit in. I want to just write the simplified form first. So limit x tends to 2 plus, right? So because the x, I want to write the x squared positive, okay? So I want to write the negative 1 outside. So negative 1 times x squared plus 2x minus 8 divided by x minus 2 times x plus 2. Let me simplify that. So that is limit x tends to 2 plus, and then negative 1 x plus 4, and then x minus 2. Those are the factors of the top, right? And then you get x minus 2, x plus 2. You see that the same common factor on the top and bottom, so you divide, that will become 1, right? So that will be, what is left is limit x tends to 2 plus negative x plus 4 over x plus 2. Let's plug in the limit. What do you get? If you plug in the limit there, you will get basically negative 2 plus 4 divided by 2 plus 2. Although it is 2 plus, we just write 2, right? So negative 6 over 4. So the final answer is negative 3/2. So the final answer is negative 3/2. So basically, we didn't have to do the LHopitals rule there, did we? So you notice that we didn't use the LHopitals rule anywhere, although it was the indeterminate form. Okay, I mean, problems can be done with or with, some problems can be done with or without using LHopitals rule. So here, if I want to use LHopitals rule, I would use right here, like this. Okay, so what do I get? Limit x tends to 2 plus, right? And on the top, I got 8 minus x squared minus 2x, right? When you simplify that, divide by, on the bottom it is x minus 2 times x plus 2 is x squared minus 4. So if you take the limit, what form do you get here? You get 8 minus 2 squared is 4 minus 2 times 2 is 4. 8 minus 8. 8 minus 4 is 4 minus 4 is 0, right? You will get 0 over, if you plug in that here, you will get 0 over 0. So you can use the LHopitals rule here, right? So if you do that, you will basically get, equals to limit x tends to 2 plus, let me write LHopitals rule there. So 0 minus 2x minus 2 divided by 2x, just 2x, right? Because the derivative of x squared is minus 8 is 0, derivative of 8 is 0, derivative of negative x squared is negative 2x, minus derivative of 2x is negative 2, divided by derivative of x squared is 2x, and then minus 0, right? Minus 0. If you plug the limit, what do you get? So basically, you will get limit x tends to 2 plus negative 2x minus 2 over 2x. If you plug in the limit, you will get negative 2 times 2 is negative 4 minus 2 is negative 6 over positive 4. That is negative 3/2. So basically, instead of doing all these other steps, you could do the LHopitals rule after you get the fx over gx form, right? After you get the f over g form, because here you had minus in the middle. There are two different terms. But after you get a single term or f over g form, a rational function, then you will be able to get the LHopitals rule if it takes the indeterminate form. Okay guys, thank you very much. That's the end of the videos for this section.